Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.
Welcome to the Federal Tech Podcast. My name is John Gilroy, and I will be your moderator. Our guest today is Mike Wiegland. He is the CGO and co-founder of a company called Shift5. Now, because I'm obsessive compulsive and spent decades on the radio, I'll spell it out for you. It's the word shift, S-H-I-F-T, then the numeral 5, and .io. And you can go to the website and you can see all kinds of different things to do. There are all kinds of videos about trains, about planes, and about the military. And that's the topic of our conversation today. We're talking about trains and planes and militaries and security. But before we begin, I'm going to have Mike maybe a thumbnail sketch of the company and how they can help our federal audience here.
John, it's great to be here on the FedTech podcast. Shift5 is a fleet data company, and we are also a dual-use company. We were founded originally to solve cybersecurity problems on weapon systems, commercial airliners, and railroad locomotives. But in the course of solving that problem, we built a solution that now helps democratize data and solve a variety of maintenance, operational readiness, operational sustainment, and cybersecurity problems, focusing on what we call operational technology, the really unique and what I think is really cool data bus technologies that allow all the onboard computers to talk to one another that make these exquisitely complex aircraft and ground vehicles and maritime assets work. And be as effective as they are.
Well, Shakespeare used to talk about things trippingly in the tongue, and then you use that word dual use, that phrase dual use, very trippingly. And there are some people who are listening to this that know exactly what it is, and some people that don't. I'm going to try to give you my kind of layman's interpretation of what it is. I always thought dual use was like a Swiss Army knife or something. But I think in this context, what dual use means is technology that is used in the commercial world that also can be applied to the military world. Is that a working definition we can start with?
John, absolutely. You nailed it on the head. We're very fortunate to be able to serve both federal and defense customers and also the commercial sector and some of the most what I view as important critical infrastructure verticals, right? Transportation, chief among them in both the airline and railroad space.
Well, let's get down to nitty gritty. Let's get down to the bedrock here. So what exactly is it? So how does your technology allow military folks to, how to protect warfighters and how do they maintain their competitive edge anyway?
Yeah. So John, when we look at a modern weapon system, think of a fighter jet, an advanced, tank or a maritime vessel. What makes all of these things operate today really is a bunch of embedded computers that all need to talk to one another and coordinate their actions. It's critical for mobility, for communications, for sensing, for weapons delivery and targeting. It is these embedded computers and electronics that candidly make our systems so effective and provide the deterrent value, that they afford our nation. However, when we look at it from a cyber perspective, this is a type of cyber key terrain. At the end of the day, they're computers and they're talking to one another, and they're using very reliable and robust technologies. But in many cases, these systems were designed decades ago, before an era, of where what we now consider contested cyber. So there's a lot of opportunity for us to add sensoring to this key cyber terrain so that we can detect anomalies and faults and help protect, onboard systems from, would-be malicious actors. When we do that and we add in sensors to monitor for any type of nefarious activity in this cyber terrain, under the skin and armor of these assets, we also get access to some of the most important and key data on these platforms. Getting that data off the platforms and democratizing it enables us to solve a variety of maintenance and operations issues that in the past just were inaccessible to us because we didn't have the infrastructure, the hardware, the software, and the concepts and procedures to collect and aggregate and translate this data and then make use of it with modern algorithms and techniques. So Shift 5 does all of that. And it's a really exciting space. We're privileged to work on some of the most incredible engineering marvels for some of the most demanding customers in some of the most exciting mission spaces, I think, anywhere in the world.
Your website talks about an onboard data company. And if you do research on that phrase, you find out that it's used by marketing companies as well. It's used for a lot of different purposes, and this is a unique purpose we're talking about here. If you go into the world of digital marketing, they talk about transferring data offline to online. And so what we're trying to do here in your case is take data that's generated by multiple points all possibly across the world and bring it all together in one place and make sense of it. I mean, what are you going to do before breakfast? I mean, that's a pretty challenging job, isn't it?
It's an incredibly challenging job. So, when you think of some of the requirements and the operating environments that the systems that we, help tap and democratize data off of, they're operating in some of the most hostile, environments known to mankind. The environmental conditions and testing is really challenging. The data volumes and the specific and very unique and complicated protocols that are used on some of these mission critical applications, force an approach that, candidly is unique in the area of cybersecurity. And, so it's real exciting. Every day we get to come in and we have to solve new engineering and data challenges. And we get to bridge this gulf between, complicated system design and architecture and, the world of operations research, cybersecurity, and, prognostic, conditions-based and predictive maintenance, data science.
Last week, I was having a conversation with Colonel Oil from the Space Systems Command, and she's tasked with buying equipment for state-of-the-art activities in satellites in space. And what she told me, she said, why in the heck would she design something and build it herself when she gets something that's custom off the shelf or something right off the shelf? It saves money. Now, that sounds real good if you're running Michael's Donuts or John's Transmission Shop, but you're not. I mean, you're in a position where it may be cheaper for you to go with a commercial product than a dedicated military product. So where do you draw the line between public-private partnership, especially with some of the secure information you're handling?
Absolutely. Well, I think some of the advantage of being a dual-use company is that, the commercial operators, they optimize for slightly different use cases than the defense, market does as well. And, each's unique focus actually complements the other's operations. So what we try to do is bring this middleware infrastructure of hardware and software that can be easily plugged and played into existing systems or new systems that are being built to very efficiently solve specific requirements around, data collection, edge computing, maintenance, operations sustainment, and obviously cyber protection of the digital architecture and terrain on these platforms. The more systems that we get on in different domains, air, land, sea, space, and subsea, candidly, the more efficient that we can offer this, family of solutions to our customers. So, especially in the defense market, our capabilities always have to be tailored because every satellite, as a specific example, is unique. But many satellites use common data bus technologies, and they try to use the same, rad hard, processors and architectures that have been battle proven, if you will, on prior constellations. And so, it's just good business and sense to, I think, to the maximum extent feasible, leverage commercial off-the-shelf solutions that can be quickly and easily tailored, to government applications. And candidly, the commercial market likes to do that as well for their applications in rail and in aviation.
Mike, I love talking about the Space Force. I love talking about laser communication between satellites. But let's put our feet in the ground here. I mean, literally on the ground here. I think everyone who's listening to this knows there was a little incident in Ohio with a little train, and there's a problem there. And if people are figuring out that there were sensors, that's going to peek up here, sensors on the tracks there. So maybe you can give us maybe a view from your office window there of the problem and how it's been addressed and how you can maybe step in and help the situation.
Yeah. So, John, my understanding was that, we had a car derailment, and unfortunately it was carrying hazardous cargo and pretty pretty awful environmental situation, but a car derailment from a mechanical breakdown. One that, candidly is probably impossible to completely reduce the likelihood of ever happening. When there's a failure associated with the bearings around the wheels in the truck of a car, and that car's moving down the line, it's going to create friction. Friction creates heat. Eventually, you're going to have, metal's going to melt. Things are going to come off the rails, and you're going to have a problem. So, how the freight industry monitors and attempts to address this risk is by having these wayside detectors. Every generally 20 miles or so, they're going to have a detector that will look for any kind of equipment that's being dragged by the cars, like a brake hose or something else like that. Maybe at the the end of the line. It's also going to have some sensors to try and detect if there are hot spots associated with those wheels in the trucks. And so in this case, everything actually worked according to plan, as I understand. The detector detected that there was a hot wheel condition, an alarm was sent up, and the crew reacted appropriately. Unfortunately, just timing of the incident, the derailment was probably going to happen one way or the other. There are technology solutions to address this. That's not the industry and the business that I'm in. What I want to make sure that the freight railroad stays ahead of is making sure that the electronics on the locomotives stay secure, that they have good, clean software and firmware controlling the engine, controlling the traction motors. That's literally what converts the electricity and makes them go. I want to make sure that the operators, right, that engineer and the conductor are getting good indications from either their computer screens in the cab, and that nothing is being manipulated by an adversary. Just like how we have computers in our office. Those guys have computers that they use to, control most of those high power locomotives on mainline operations. So what Shift 5 offers to the freight, to the freight railroad market and also to the passenger market is, hardware and software solutions to monitor for any kind of tamper or cyber intrusion or malware on those onboard computers, and give confidence to, the railroad and its employees that they have, good, trustworthy software and hardware that they're using to, to haul cargo.
Michael, there's a podcast in town called Feds at the Edge. I think that almost should be your motto for your company there. I mean, you're at the edge when it comes to railroads, when it comes to planes, when it comes to satellites, when it comes to so many different areas. And I just think it's fascinating. So let's talk about airlines. My neighbor over the weekend, he has an old Subaru, and he changed out the O2 sensor in it. Man, no big deal. As long as you don't strip it, you're fine. Pretty easy to do. Now, if you get a 737 and there's a sensor problem, that might be a little more difficult to do. And I don't think people realize the expense that it takes to maintain like these large 747s or these. I mean, the maintenance can cost millions of dollars to do that. And I think what a lot of times what the sensors can do is it can inform people and say, hey, look, X, Y, and Z is happening here. You may want to do this because of that. And it sounds just so simple. It sounds like, oh, it's just a little command that Michael. No. This could save hundreds of thousands of dollars, just one small component like that. And so when you can't disregard the value of these sensors, can you?
No, John, you can't. So the world of avionics and, the computers on board our modern airliners that make them operate so efficiently and reliable is fascinating technology that's been honed over decades. And actually a lot of defense innovation has enabled, the modern conveniences and efficiency that we take advantage of, when we fly with the airlines. So what, Shift 5 aims to do to help that market is make sure that we are collecting all of the data between onboard, key computers and avionics on board these aircraft. Now, today, a lot of advanced systems like airliners, they report out maintenance faults. They automatically can sense certain, fault conditions, and they can send alerts and indications. Some of that actually sent over the air while a plane is flying, so that maintenance crews on the ground know, that, hey, we might have a plane coming in that needs quite literally, an oil change out of schedule, or is going to need somebody to go check and look at something. However, there are all of these types of unique issues that can come up that are called no fault found maintenance conditions or other types of events where, there isn't a fault, but it's causing secondary systems to fail and an investigation needs to happen. A fault code at the end of the day required some engineer to think about a failure case in advance and write some computer code to look for that specific indication or signature and then provide an alert indication, right? So what we provide is the ability to collect all of this other data and make it accessible to the community of interest, right? The integrator, OEM, the avionics manufacturer, and the operator, so that we can reduce those no fault found instances, so that we can get to root cause analysis of maintenance failures and other issues faster, and ultimately keep planes in the air flying where they're helping generate revenue and provide customer service at a higher rate. So that's at a very high level what we do there. But again, the technology, the problems, the regulatory space around that is really fascinating. It's complex and it's bulletproof tech. We want to make sure that everything stays reliable and safe as we enter, the later half of the century.
Yeah, the phrase predictive analytics comes to mind here. We're taking many different data sources and trying to make a conclusion from it. At your website, there's a phrase used called future-proofing. So is that essentially what you can do with many different types of equipment through use of sensors and advanced diagnostics?
We think so. So just by recording the existing data between these different computers talking on a plane or a train or a tank, we think that by collecting 100% of that data on the edge and being able to get that data off the platform, whenever and wherever possible, centralizing it, it enables, folks to solve problems that we can't envision today, but that might happen down the line. That's what we mean by future-proofing. In our case, we aren't actually adding new individual sensors to platforms. We're using the existing communications and viewing the system as its own set of sensors in a way that hasn't traditionally been appreciated by the industry. When we put an advanced aircraft through flight qualification, we have all of these orange boxes and orange wire, data collectors and data historians and monitors when it's going through flight test. And then we take all of that stuff off when it gets qualified and you start mass producing something and it gets into production. Effectively, what we think is, hey, let's build a very size, weight, and power efficient system, tap all of that and collect all of the data, because candidly, data storage is inexpensive these days. And there's tremendous unappreciated value in collecting all of that operational fleet data that will allow us to solve problems that we really just haven't envisioned and appreciated moving forward. So that's some of the core thesis in what we mean by future-proofing.
And so if you were to look into the future and try to who could have predicted what happened in Ohio? No one could have predicted that. But you're in so many key points that you've seen. So where do you see this whole technology evolving in the next few years?
Well, in the next couple of years, we aim to, continue to identify new use cases and uncover new ROI using this data for our commercial and our federal customers. Again, we started doing kind of, cybersecurity baselining systems, looking for anomalies and making sure that good, clean software and firmware was running on all the embedded computers. And that's important for safety and the survivability of our weapon systems in a contested environment. However, we now appreciate that there is tremendous value in improving maintenance processes and increasing the uptime and availability of these incredibly expensive, fleet assets, locomotives, commercial aircraft, and military vehicles. And as we move to the future, I think that we're going to uncover that the data can also be useful to inform operations and to help make business decisions faster. This data incorporated with all of the other advanced, kind of business logic that's already put into place in these various industries, it's going to be complementary to the existing data transformation initiatives that we see, the railroads, the airlines, and the military, continuing to advance across their organizational interests.
Sometimes companies just are at the right place at the right time. And what I see now is this whole move to the edge. And you obviously have the qualifications for that. In fact, there's a brand new acronym that people in the federal government and the commercial world are starting to use. It's called Secure Access Service Edge, SASE. And different people have different conversations about it. Some people say, at what point do you compute at the edge? At what point do you intermediate? At what point do you at the data center? And how is that distributed? When it comes to satellite information, there's laser communication between satellites. And at what point do you make the connection to the ground station? I mean, so this whole idea of at the edge, I think in the next few years, the real question is going to be, well, where do we compute? I mean, is that a question that's brought up even now?
Well, the way that we think about it is, getting all of the data off these assets when they are in a place where they can communicate and send that high volume data. That's really helpful to solve all of the problems that we just discussed around future proofing and operations insights, et cetera. But there are a lot of cases where you don't have connectivity, or it's not reliable, or you want to provide some type of indication and prompt some type of crew action without having a live data link. So we think that folks need to think very, very carefully about that. And we have in our product architecture, right? We support disconnected operations where the operators of a specific vehicle get certain indications from certain types of, anomaly detection or other logic. Typically those alert indications that, the crew have already been trained to take certain actions when they get it. Hey, I see this happen. I don't need a data connection. I know what I need to do to, continue to affect my mission. But where we can have, and when we can have, real-time data links, getting that data off and up to, higher headquarters in the military, or, to an operations center in an airline or in a railroad, enables a level of planning that's helpful to keep things just moving. So we think very consciously about that, how much processing and what kind of processing and data store needs to happen at the edge, how the connectivity model works, again, across very austere and, in some cases contested communication environments, and then how to get all of that data centralized, translated, and then reviewed so that you can find inferences across a fleet of assets and identify things that are odd or off in the ones and twos, find those needles in the haystack. That's also tremendously important, but all of that has to happen again, back office in the cloud. So it's a really complicated, I think, conversation, and one that is unique to each market and in many cases to each individual customer.
It's my job to read the executive orders that come out, and the last CEO mandated that every 15 minutes I have to say the word cybersecurity. So, man, I have no choice. And you haven't said the word. So, Michael, you're going to have to do some push-ups now or something, because this hasn't come up in this conversation. I think when I talk about, going to Joe's Donuts, I talk about cybersecurity or something. So this has got to be baked into everything we spoke about today, isn't it?
Yeah. So, John, we have really strong conviction that the more automation, the more compute, the more autonomy that get baked into all of these expensive fleet assets, the more important the cybersecurity of these embedded computers and the networks that they use to communicate with one another is going to be. I think it's actually that simple. When we think of the proliferation of unmanned aerial assets and their application in defense, and we think of what that can look like in the commercial market, I think everybody agrees that having some type of cybersecurity solution, on a device that's operating in the physical world where software is controlling those physical outcomes, that's just common sense. So we're positioning ourselves to offer solutions to those, OEMs, those integrators, and the specific subsystems or avionics manufacturers that are supporting, this new wave in aviation.
So, Michael, final question here. I made a silly reference to feds at the edge, but increasingly feds are more and more at the edge, whether they can be working at home, whether they're in a satellite, whether they're at the edge of a battlefield somewhere. So in the next 5 years, where do you see your company growing? Is it going more and more into the commercial area, more into military area, or kind of a blend? Or where do you see your company heading in the next 4 or 5 years?
Well, John, we are unabashedly, defense first. 1 in 5 Shift 5 employees is a veteran, and we're really motivated and focused on the national security mission. But we see the commercial, potential for our company as it's going to be a really exciting proposition in the coming years. Again, as more automation, finds its way into the railroads and into, increasingly sophisticated glass cockpit systems and fly-by-wire aircraft come out from our aircraft OEMs, we see, an increasing need and opportunity on that data exploitation side for operations and other, enhancements, kind of growing in the commercial market. So I think in the next couple of years, we'll see the commercial business kind of catch up to what we're doing in federal, and in the future, certainly it's gonna surpass, because it's just a much larger market in general globally.
Well, I think you've given our listeners a better idea of what onboard data is all about, and maybe some earmarks for to look forward into the future. You've been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Mike Wiegland, CGO and co-founder of Shift 5.
Thanks. Have a great day.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.